Hi guys, Daniel here, and today we're going to do, as a practice for Amy, an HMMT problem from HMMT February 2016 Geometry Section, problem number 3. So first, let's read the problem. We have a equilateral triangle T with side length of 5 and a circle omega with a radius of 2. And the triangle and circle have the same center. We have two areas, X being the shaded and Y being the starred. And we want to find X minus Y. So at first this problem might look really hard because the shapes are quite strange. We see that the Y we are a little bit more familiar in finding because it's the difference between the area of a sector and the area of a triangle as shown by connecting the center of the circle to the intersection points. So we can let Y equal the area of this sector minus the area of this triangle. So motivated by this idea, we can maybe also find an expression for X in terms of a difference or sum of areas. And in fact, taking this diamond minus this smaller sector works. So now we can find the areas of these four shapes individually and then evaluate X minus Y. But I'm lazy and it seems like a really long and tedious task, especially finding the area of the diamond. So instead I'm just going to calculate X minus Y in terms of these four shapes. So X is the diamond minus the little sector, and minus Y, so minus the big sector, minus a negative, which is plus the triangle. So now what do? Well, we can recognize the subtraction of these two sectors is in fact just the subtraction of a bigger sector, which is this sector in green. So this entire thing is in fact subtracting this bigger green sector. And similarly, we can look at these two shapes and see that they actually combine to form this quadrilateral right here. However, how do you find the area of this quadrilateral? It's not as nice as the sector, and it doesn't seem to have any nice properties. However, there is one nice property about it. If we connect this line right here, then we see that these three quadrilaterals formed are in fact identical. So it turns out that this is actually 1/3 the area of the triangle. And of course, we also can find that this is 1/3 the area of the entire circle. So now we've simplified this problem immensely because X minus Y is simply equal to 1/3 the area of the triangle minus 1/3 the area of the circle. Like so. And now to finish off the problem, we just need to recall the formulas for areas of equilateral triangle and area of circle. The equilateral triangle has side length of 5, which means that its area is 5 squared, 25, times the square root of 3 over 4, and the area of the circle with the radius 2 is 2 squared, which is 4 times pi. And finally, we want to times the entire thing by 1/3, and this simplifies to 25 times the square root of 3 over 12 minus 4 pi over 3, and we have our answer.
Today we're going to be doing AMC 10A 2016 problem 24. I would do AMC 10B problems, but technically I'm not allowed to discuss them till